Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we consider some examples. Let us consider example in bracket d square minus 4 bracket complete into y equal to x square. In the solution we first write given equation. Auxiliary equation is bracket equal to 0, that is d square minus 4 equal to 0. Hence we get d square equal to 4. Taking square root we get d equal to plus minus 2. Here roots are real. So complementary function is c1 e raised to minus 2x plus c2 e raised to 2x as roots are plus 2 and minus 2. This complementary function can also be written as cf equal to c1 e raised to 2x plus c2 e raised to minus 2x. Now we consider particular integral. Particular integral equal to 1 upon d square minus 4 operated on x square. Here operating factor is in the form of x raised to m equal to 2. So we write here this fd in ascending powers of d. We take constant outside and hence in bracket we get 1 minus d square by 4 bracket complete. So finally we get minus 4 plus d square after simplifying. Operating factor is x square. Now we take this bracket in numerator. So power is minus 1. So we get particular integral equal to minus 1 by 4 into bracket 1 minus d square by 4 bracket complete raised to minus 1 operated on x square, which is equal to 1 by 4 into bracket. We expand this bracket 1 minus d square by 4 raised to minus 1 as 1 minus d raised to minus 1 equal to 1 plus d square plus dash dash dash. So we get particular integral equal to minus 1 by 4 into bracket 1 plus d square by 4 plus 1 plus d, that is 1 plus d square by 4 plus d square, that means square of the term, d raised to 4 by 16 bracket complete operated on x square. Here derivative of x square equal to 2x, d square of x square equal to 2 and d cube of x square equal to 0. So we take only terms up to 1 plus d square. Since if we take next term d cube, that means cube of this term, then derivative of x square will be 0 there. So we take only these three terms operated on x square. Now we operate this x square in bracket. So we get particular integral equal to minus 1 by 4 into bracket x square plus d square of x square is 2. 2 by 4 plus d raised to 4 of x square is 0. Bracket complete, which is equal to minus x square by 4 plus minus 1 by 8. Adding CF and PI, we get complete solution, that is y equal to c1 e raised to minus 2x plus c2 e raised to 2x minus x square by 4 minus 1 by 8, which is complete solution of given example. Now we consider another example. Solve d cube minus d square minus 6d in bracket operated on y equal to sin x plus x square. Here we first write the solution. Here we first write given equation in the solution. Here auxiliary equation is bracket equal to 0 and this term can be written as d into bracket d square minus d minus 6 in bracket complete equal to 0. So we get d equal to 0 and d square minus d plus 6 equal to 0. Here sum is minus 1, product is 6. So that we get the roots of this equation as sum is minus 1, product is minus 6. So we write this term as d square minus 3d plus 2d minus 6 equal to 0 and d is equal to 0. That means here we write given equation in the solution. Auxiliary equation means bracket equal to 0. Then we take d common. So we get d equal to 0 and d square minus d minus 6 equal to 0. We factorized it. So we get d equal to 0 and d minus 3, d plus 2 equal to 0. So we get d equal to 0, d equal to 3, d equal to minus 2. So complementary function is c1 e raised to 0x plus c2 e raised to minus 2x plus c3 e raised to 3x. Or we can write it as c1 e raised to 0x plus c2 e raised to 3x plus c3 e raised to minus 2x also. But e raised to 0x is 1. So that complementary function equal to c1 plus c2 e raised to minus 2x plus c3 e raised to 3x. Now we consider particular integral. Particular integral equal to 1 upon d cube minus d square minus 6d operated on sin x plus x square. Here operating factors are 2. So we separate them. So we get particular integral equal to 1 upon d cube minus d square minus 6d operated on sin x plus 1 upon d cube minus d square minus 6d operated on x square. We know that when the operating factor is sin of ax or cos of ax, then we put d square equal to minus a square. Here a equal to 1, so we put d square equal to minus 1 square into d minus 1 square minus 6d operated on sin x. So we get here minus d minus 1 minus 6d, or this can be solved in another method also. Here second term is 1 upon d cube minus d square minus 6d operated on x square. Here operating factor is in the form of x raised to m, it is x square. So we write the fd term as d into bracket d square minus d minus 6 bracket complete operated on x square. Here in the first term we take d common, so we get 1 upon d into bracket d square minus d minus 6 bracket complete operated on sin of x. Now particular integral equal to take 1 upon d into bracket put d square equal to minus a square, so that we get minus 1 for d square. We put d square equal to minus a square, so that we get minus 1 minus d minus 6 operated on sin x bracket complete plus 1 upon d. Here second term is 1 upon d into bracket d square minus d minus 6 operated on x square. So we have to write this bracket in the form of 1 plus minus 5d. So we write the bracket as in the form of 1 plus 5d by taking minus 6 outside the bracket operated on x square. Here the same term is calculated here by another method, that is we put d as it is and d square equal to minus a square, d square equal to minus a square, that is minus 1 square minus 6d. Same term, that is minus 1 square is minus 1 minus here minus d minus 6d, that means minus 7d minus 1. Same term comes here. We take minus sign common. That means we can do these calculations by any method. So we get particular integral equal to, by taking minus sign common, minus 1 upon d into bracket 1 upon d plus 7 operated on sin x minus 1 upon 6d into bracket 1 minus d square minus d bracket upon 6 bracket complete bracket big bracket complete raised to minus 1 operated on x square by taking this bracket in the denominator in the numerator. So power is minus 1. Here operating in the denominator, that is fd is d plus 7 and operating factor is sin of x, that is there must be factor in the form of d square. So we rationalize this term. So we multiply numerator and denominator by d minus 7 for this operating factor sin of x. So we get in the first term particular integral equal to minus 1 upon d into bracket d minus 7 upon d plus 7, d minus 7 is d square minus 49, that is a square minus b square operated on sin of x. And after simplifying this, minus 1 upon d in bracket d minus 7 sin of x upon d square equal to minus a square, a is 1. So minus 1 square, that means minus 1 minus 49. So we get minus 1 upon d in bracket derivative of sin x is cos x minus 7 sin x upon this minus 50. Then we consider second term, minus 1 upon 6d into bracket. We expand this bracket by using the formula 1 minus d raised to minus 1, and we take first three terms. Since derivative of x square occurs only 2 times, that is d of x square is 2x and d square of x square is 2, d cube of x square is 0. So we get, after expanding, we get 1 plus d, that is d square minus d upon 6 plus square of the bracket, that is d raised to 4 minus 2d cube plus d square upon 36 bracket complete operated on x square. Then we operate this x square in bracket. So we get minus 1 upon 6d into bracket 1 into x square is x square. D square of x square is d square of x square is 2 and d of x square is 2x, that is 2 minus 2x upon 6 plus d raised to 4 of x square is 0, d cube of x square is 0, d square of x square is 2 upon 36. So we get, in the second term we get minus 1 upon 6d into bracket x square minus x by 3 plus 2 by 36, that is 1 by 18 plus 1 by 3. 1 by 18 plus 1 by 3, that is 7 by 18. Now we simplify these terms as 1 upon d means integration. So we integrate these terms. So we get integration of x square is x cube by 3 minus x square by 3 into 2 is 6 plus 7 7 by 18 into 7x by 18 bracket complete. And in the first term here 1 upon d into bracket this result. So we integrate these terms. In the first term we get integration of cos x is sin x minus 7 by 50, that is 1 by 50 taken outside. Integration of cos x is sin x minus 7, integration of sin x is minus cos x. So we get here minus minus plus, here plus sign must be there. So we get particular integral as 1 upon 50 into bracket sin x plus 7 cos x minus x cube by 18 plus x square by 36 minus 7x upon 108. Adding CF and PI we get complete solution. So we get y equal to C1 plus C2 e raised to minus 2x plus C3 e raised to 3x plus 1 by 50 into bracket sin x plus 7 cos x minus x cube by 18 plus x square by 36 minus 7x upon 108, which is y equal to C plus Pi as y equal to C1 plus C2 e raised to minus 2x plus C3 e raised to 3x plus 1 by 50 into bracket sin x plus 7 cos x bracket complete minus x cube by 18 plus x square by 36 minus 7x upon 108, which is complete solution of given equation. Thank you.